Sophia, you tell me when you want me to change it.
Okay.
Sophia
so
just presented this paper in Singapore.
Yeah, I present this paper. I think I present the machine learning part, and the Kashin present the first half of this paper. So basically, this paper try to solve a very practical problem, because in the industry of insurance industry, they make a lot of accounting estimate about the loss. So for example, in the car, so if a customer has a car accident and they will make a claim, and we need to determine what is the loss for this car accident. So that is one of the examples that we just discussed about the accounting estimate. And in the past, we always use the manager, the human manager, to make this estimate about what would be the possible loss. So that is what we used to do. So can you go to the next? Yeah. So however, the problem here is the accounting estimate. They are highly uncertain. And sometimes in order to achieve some of their objectives, the managers try to manipulate the results. And so this makes auditors very difficult to audit what would be the accurate number with amount of those loss. So we try to propose our machine learning algorithms, machine learning models, and we just make the same predictions on those laws for the insurance industry, and we compare the prediction of the loss with the manager's estimate, and to see if with this machine learning algorithm we can provide a more accurate loss. Can you go to the next page? Can you go to the next page, Professor Miklos?
I'm trying. It's frozen.
Fine. Let's just.
Okay, got it.
Okay, so alternatively, we propose a machine learning technique, and here on this slide they just list several benefits, their advantages of machine learning, and I believe you are familiar with it because we just talked about it. Because we can use machine learning to process a lot of data, right? So here is the basic idea of it's okay. Just go to the next page.
Is this good?
Yeah, on this page is good. So the basic problem here is we do not know what exactly the total loss of the claimed accident is until like 10 years, because usually it takes many years to solve a problem. For example, in 2010, you had a car accident and you claim you made your claim, but maybe it won't be solved. You won't get your payment until 10 years later. So it's a long time, it involves a long time period. So that's why we need a machine learning algorithm to help us. And the managers at the same time, they keep changing their estimate. They will adjust their estimate one year by year. So here we actually work on a supervised learning problem, like we just mentioned. We have our label because we're gonna use the number, the actual payment of the claim 10 years later. We consider that as our actual payment. So we already know the outcome. So we call them the label. So we have the label. So it's a supervised learning problem. And we just want to compare our prediction with machine learning algorithm with the actual payment. So if we subtracting our prediction on the loss from the actual payment, we know the error, right? And then on the other hand, we subtracting the manager's estimate, and we use the total payment 10 years later, subtracting the manager's estimate, and we still got error. So we compare these two types of error. If we can prove the error made by our machine learning algorithm is smaller than the manager's error, then that means machine learning can improve accounting estimate. So that is the basic idea. I don't know if you understand or you want me to repeat. Good. Okay. So our basic idea is try to compare the error. So can you go to the next slide?
See, file the claim.
Yeah, timeline.
Settle the claim.
Yeah.
File the claim. Settle the claim.
Usually take like 10 years. So here is an example. So if you look at the table 2, illustration of incurred loss and the cumulative pay the net loss reported in 2008 for a company. So on the top, the first half is manager's estimate. So as you can see, for the loss that incurred in 1999, which is the second line, second row. So in 1999, at the same year, the manager estimated the loss would be 4,583, right? And then the next year, in 2002, which are in the second column, also in the line number 2, which is for the year 1999, they made some adjustment. They increased the amount from 4,583 to 4,615. So as you can see, from the year 1 until we got the year 10, 2008, they keep make adjustment on their estimate. So finally, for the year 2008, the amount is 4,618. So we consider that is the manager's estimate for those loss happened in the year 1999. Okay. So the next line for the year 2000, they also did the same thing. So usually it will take like 10 years to make the final settlement, and during this 10-year period, they keep changing their estimate until they get the most accurate results. And on the bottom half, on the bottom, those are the actual payment. So if you look at the same year, 1999, and you find that the actual payment in year 2008 is 4,618. As you can see, this number exactly the same as the number on the top. So that means in the last year that the managers they made their final adjustment, try to match the actual payment, and we use this number 4,618 as our label, as our actual payment. And our test is try to compare for each year's estimate the difference between our estimate, our prediction with the final payment. And we try to pick the model which gives us the smallest error. And go to the next slide. Yes, so we're gonna compare the estimation errors. And here we just introduce several attributes that will affect our loss. So we just please skip that. And can we just go to the next slide?
The results.
Yes.
You want the techniques or you want the results?
I want the technique for now. Previous. Okay. So here we use. You guys know what the algorithms are, right? So here in this paper we use 4 algorithms. One is the most straightforward algorithm, linear regression. And as we mentioned earlier, linear regression is actually a statistical modeling method. So in the area of machine learning, we borrow this concept from statistics, and we use this as a machine learning algorithm. The basic idea is the same, but we use different approach. And then we use random forest. Random forest is a forest of decision tree. If you are familiar with the decision tree algorithm, you should know that. So for the decision tree algorithm, we try to structure a tree-like structure and try to make prediction. And so it's like a tree. We have a node, we have branches, we have leaves, and we can make decisions step by step. So those is the second. And third one is called a gradient boosting machine. And last one is artificial neural network. So if you could go to the next slide, we have more information about the linear regression. So they try to plot the data points and try to make them assume they fit a straight line, right? So it's based on the linear relationship between the numeric output and numeric input attributes. So that is the linear regression, the basic idea of linear regression. And if you could go to the next slide, that is a random forest. So here I have this GIF picture for you. So this actually try to extract information from the data and display it in a tree-like structure. And instead of using a single tree, we use a random forest. A random forest means a forest of trees. So let's assume we can make 100 trees, and each tree can give us a prediction. And for each prediction, we know what is the error, and we make a vote. And we just we're using the majority voting, and then we can identify our final prediction. So this approach is called ensemble approach. Okay. So here, as you can see on your right hand side, we have example of 3 individual model, and each model is a single decision tree. Okay, it try to attempt to predict the 10 outputs of either blue or red. And the correct predictions actually is blue for all the 10 outputs. So here we use an ensemble approach formed by majority voting based on 3 individual models, which can yield the highest prediction accuracy. So as you can see on the bottom, the ensemble model, which called majority voting, which just use, so for example, for the first output, model 1 believe is blue, model 2 believe is blue, model 3 believe is blue. So for the ensemble approach, using the majority voting, we believe that is blue, right? And for the second one is also blue. For the third one, model 3 believe is red, but we use the majority voting, so we believe that is blue. So as you can see, the final ensemble model gives us the most accurate result because it's 8 out of 10 correct. It's much better than any of these single models. So that is the basic idea of ensemble. It's called a random forest. So go to the next slide. And this is another type of algorithm. It's called a gradient tree boosting. I think it's very complex. I just want to skip that because I don't want you guys to fulfill information overview me, but you guys just need to bear in mind this is another type of ensembling method, and the base approach is also decision trees. And if you can go to the next slide. Artificial neural network. Artificial neural network is they mimic the basic structure of human brain's biological neural network, but just to mimic the basic structure, not exactly the same. So they try to use several layers, several interconnected layers, try to map the input data into output data. And as you can see here in this GIF, we have 3 layers, right? The first layer on your left-hand side is called input layer. Those layers consist of nodes. So if you see the small circles, each of them is called a node. The node is the place where we execute complex calculation, mathematical calculation. So on your left, the first layer is called the input layer, and this layer is used to receive the input data, the raw data. And if you can go back. Yes, and then when you go to the next layer, that is called a hidden layer. Hidden layer is called a hidden layer because on your right hand side, the last layer is called output layer. So the layer between input layer and output layer, we always call them hidden layer. So as you can see, the input data can go from one layer to another, can be transmitted from one layer to another. And as the layer goes further and further, we can identify more and more abstract information from our data. So this GIF actually gives us a very like a basic, simple structure of artificial neural network. And if you could see the hidden layer, right now we have only one hidden layer because we only have one layer between the input and output layer. And the output layer is used to provide our final output, our final prediction. So here we call them a shallow neural network. But if you could say there are more than 3 hidden layers between the input and output layer, we call them deep neural networks, or we call them deep learning. And deep learning has been widely used in natural language processing, like what you talk, Siri in your iPhone, okay, Alexa in Amazon. Those are all use deep learning. So we use this also as an machine learning algorithms to try to make predictions on the accounting estimate of the loss. So next slide. And as I just answered the question raised by Ricardo, we need to provide several evaluation measures, because we need to evaluate the performance of the model we developed. So here, because this is a regression problem, remember our task is to predict the amount of loss. Right? So here is a regression problem. So we use a regressional evaluation metrics. So here we use MAE and RMSE. So those are the error. So the formulas here, I think is very is self-explanatory. We use the true value of the actual payment 10 years later minus our model's estimate.
Sophia, let's go to the results because we don't have a lot of time, and I think people will see what you are doing by showing the result. So I'm moving to the next table.
Okay, so here is the major results. So we basically have 1, 2, 3, 4, 5 business lines. And if you could compare, we have the manager's estimate measured by MAER, MC. Those are the measures. And we have our machine learning's result. Without the manager's estimate and with the manager estimate, what does that mean? That means if we have a machine learning algorithm and we do not use the manager's estimate as one of the independent variable, as one of the predictor, then it is the result of machine learning without the manager's estimate. And the last part is machine learning with manager's estimate, which means in the process of developing our machine learning model, we use manager's estimates as one of the predictor. So as you can see, the results is pretty constant. If you just take a look at the commercial auto liability line, and we found that for the random forest approach, which is our best approach, our accuracy for the RMSE is 14,051. And if you look at the manager's estimate for the same RMC, they are more than 18,000. So our error is lower. And also for the MAE, for the same line, our error is 3,565, and the manager's error is 4,209. So that means our prediction power is better than the manager's estimate. So that means we make a more accurate prediction. And those results is consistent, except the one line. And if you could go to the next table. Yeah, those are the continuous main results. And just go to the next one. It has the most, for the holdout test results, we hold out a subset of our data, and we use this data, and we apply our model, and we make predictions on this holdout data, and we make one more prediction, try to give us the most robust result. And the result is consistent. Our machine learning model always outperform the manager's estimate in terms of the loss. Next one. Yeah, and we did some additional, I just want to skip that part for the additional analysis. Yeah, to conclude, so we found that our machine learning model outperform managers' estimate in terms of evaluate the loss in the insurance industry. And we believe that there is an urgent need try to enhance the qualities of accounting estimate because it is very hard for the auditors to make test or evaluate the reliability of the estimate if those are only solely based on the manager's personal judgment. So we need a machine learning approach stand out as a benchmark to provide a benchmark for the auditors to make their decision. So maybe we can just generate the results and we use machine learning approach and we can use that to make predictions on other accounting estimates like a fair value and bad debt expenses. We can do a lot of more researches on that topic. That's about this paper.